The skin is 1 millimeter. And here is T infinity, and the surface is Ts. Where Ta is equal to 37, Ts is equal to 30 Celsius. We're given the heat flux through the skin is equal to 1.05 times 10 to the negative 10 to the 4. And we're trying to find K. We can solve it in two approaches. First, we can do so we know the Q conduction is equal to negative K dt over dx. We can rearrange it for K. So Q conduction dx over dt will be equal to negative K, giving us K equal to negative Q conduction dx over dt. We know that dx, the thickness, 1 millimeter, dt, temperature difference, 30 minus 37, which is negative 7, and negative Q conduction, we're given 1.05 times 10 to the power 4. And if you calculate that, we're going to get 1.5 watt times Kelvin. That's our thermal conductivity. We can also solve it in another way, using the thermal resistance. According to thermal resistance equation, the heat transfer Q, heat transfer rate Q dot is equal to delta T over thermal resistance R. And thermal resistance R is equal to length over area times K, at least for the thermal, and this is because it is conduction. And if this were for conduction, we would have a 1 over AH, but we are not doing convection. We can combine this equation, Q delta T over L AK, and rearrange it so that delta T times A dot K is equal to L. Here we are interested in K, so we're going to rearrange it for K. So K, so L goes up, delta T, A goes down, Q up. Well, it is to be noted that this Q is, so small q is actually big Q over A. That means this small q times A is equal to big Q. So we're going to replace that. So we have heat flux times area. And these two surface areas are going to cancel out. We're left with this. And we can just plug all the numbers in. So 30 minus 37, L is 1 millimeter, and Q is 1.05, 10 to the power of 4, which will give us same number of 1.5. And the second, instead of just bare skin, we'll have clothing layer or insulation layer, which have a double the thickness of the skin. Instead of 1, it's going to have 2 millimeter of thickness. And the surface temperature is same as 30 Celsius as before. And this will have half the K. And we're looking for the temperature at this interface, which I'm going to call CS, clothes and skin, and the heat flux through the skin. We can also solve it in 2 ways. We know that, so we know the Q conduction from clothing to skin, that, so now skin to clothing is equal to Q conduction from these the back of the body to through the skin. So I'm just going to call this a body. So body to skin. So it goes that way. So basically this is through the skin and this is through the clothing. So we're going to put all the clothing numbers here. So Q conduction is same thing, dt over dx. But since we're primarily concerned with skin, we'll have a skin K, and then this is going to be for the clothes, so it's going to be 2, 1/2. And dt here is 30 minus TCS at this temperature at the interface over so dx. So this, we're doing clothing here, so it's 2 millimeter. On the right side, we have dt, so temperature difference between a skin surface, so we have TCS minus 37 Celsius. And then the thickness is 1 millimeter. And we can rearrange it to solve for TS, the temperature, TCS. So we're going to move it around a bit. Let's move K to the right, to the left. So the negative sign cancels out. And we can move this to the right. So multiplying 2 millimeter divided by 30 TCS. And this K and K can cancel out. This 1 and 2. So this cancel out to become 2. And this 2, we can divide by 2 again to make it 1/4 on the left. 37 minus 37, 30 minus TCS. And we're going to move it to the left again. 1/4 TCS minus 37. We're going to bring it up and continue. So 30 over 4 minus TCS over 4 equal TCS minus 37. We're going to isolate this TCS by moving all to the right, to the left, 4 plus 37. So we have 1.25 TCS equal this number. And so this becomes this is 7.5. So that's 44.5. So TCS is going to become 35.6 Celsius. And that is the temperature at the interface of skin and cloth. So we've gotten this first one. So what is the heat flux? The new heat flux of the skin. And it's very simple. You can use either this, the heat flux through the clothing, or through the skin. Gonna be K dt over dx again. Let's do skin. So 1 millimeter and then 35.6 minus 37. And we know this K is 1.5 as given in the problem. And we should get 2100. So that is the first way to do it. You can also do it in a different way.